Today, I'd like to share our Arduino-based heart rate monitor. So it uses a pulse sensor to detect your heartbeat and display real-time data on OLED screen and also gives audio-visual feedback with a buzzer and LED. So this project is like a mini health assistant. So it tracks your pulse and calculate BPM and show it on a tiny OLED display. So every heartbeat triggers LED flash and a soft beep. So this is a component diagram of our project. The pulse sensor detects heartbeats from your finger and sends signals to Arduino. So Arduino counts heartbeats and calculate BPM. According to that data, OLED display shows real-time pulse graph and BPM. So lastly, LED and buzzer flash with each heartbeat. So this hardware component part is the same concept as I mentioned earlier. Arduino acts as the brain, and the pulse sensor clips to your finger and read the blood flow. An OLED display your heartbeat like a hospital monitor, and buzzer give instant feedback like a heartbeat drum roll. So in this circuit diagram, connecting everything is similar than it looks. The pulse sensor plugs into A0 and OLED use just for 12C wires, and buzzer and LED connect like party lights, pin 8 and pin 13 accordingly. So now you might want to know, how does it detect a heartbeat? So imagine the sensor as a tiny flashlight checking blood flow. So when your heart beats, more blood flows and the signal gets stronger. So our code spot those signals and count them for 15 seconds and calculate your BPM according to this formula. So no medical degree required. In the software part, it reads the sensor 100 times per second. So spot beats using a smart threshold to ignore noise, and updates OLED with a live scrolling graph like ECG. So our application is not just a cool small device; it is practical. So people who enjoy fitness use this to track their workouts. So hospital can monitor their patients in a more affordable way using the same technology. And also even a smartwatch rely on similar sensors to measure heart rate. So in the future, the system could include Bluetooth, so it can connect and synchronize data with your phone. Now I'd like to share the demonstration part of our project.
As you can see in the demonstration, let's take a look how the code is working. For the first line of the code, we need to include the serial peripheral interface library, which enable the communication with device using SPI protocol. And next is include a wire library for IC2 communication, which will be used to communicate with the OLED display. And the next one we include the output graphic library to provide the drawing function for the display. And next is include the specific library for HS 110X series OLED display. Uh, and the next part is color definition. We define the color constant if they haven't been defined already for monochrome display. Black is 0 and white is 1. Next is the display configuration. We define the dimension of the OLED screen, which is 128 pixel wide by 64 pixel tall. And next we set the reset pin to -1, which means we are not using the dedicated reset pin. And we create a display object for the HS1106G OLED display with the specified parameter. And the next line is variable to track the last time heart rate reading and result update were performed. This line is the time interval. Read the heart rate sensor every 24 milliseconds and update the BPM calculation every 10 seconds. This line is a variable to store the analog reading from the pulse sensor. And this line is the pulse sensor is connected to the analog pin A0. And the LED pin for visual heartbeat indication is on the digital pin 13, and the buzzer pin for audible heartbeat indication is connected to the pin 8. And next one is threshold value to detect heartbeat. When the signal goes above the upper threshold, it's count as a beat. And next one is counter for heartbeat. Next one is the flag to prevent multiple counts for a single heartbeat. Next is beat per minute value. And this phone line is a variable for drawing the heartbeat graph. And for all of this is used to bitmap data for a heart icon stored in a program memory to save RAM. This is the setup function. We configure the LED and buzzer pin as the output and initialize serial communication at 9600 baud for debugging. And the next one, we initialize the OLED display at IC2 address 0xT3. If it's failed, print an error message and enter in infinite loop to halt execution. The next line, we update the display with the default output splash screen and wait for 1 second. And all of this is clear the display static property and show a message asking the user to wait for 10 seconds, then wait 3 seconds. Next is prepare the main display layout, clear the screen and draw the heart icon at the bottom. Draw a horizontal line to show initial is 0 BPM text. Next is to print a message to the serial monitor and end the setup function. Next is main loop function. The main loop simply call the get heart rate function repeatedly. And next is a function to read the pulse sensor and calculate the heart rate. Next is to check if it's time to read the sensor. Next is used for read the analog value from the pulse sensor. And in this if the signal exceeds the upper threshold and we haven't already counted this peak, increment the heartbeat counter, set the threshold start to false to prevent recounting, turn on the LED and briefly sound the buzzer at 1000 Hz. Next, if Uh, if the signal falls below the lower threshold, we reset threshold start to true, ready to detect the next bit, and we turn off the LED and stop the buzzer. And next we have to update the heartbeat graph display, and we check if it's time to update the BPM calculation for every 10 seconds. And next is calculate BPM by multiplying the heartbeat count by 6, since we counting for 10 seconds, which is 1 for of 6 minutes. Output the BPM value to the serial monitor and its display function to update the OLED display with a new BPM value. We clear the previous text area and we redraw the hard icon and horizontal line and display the new BPM. And this line used to reset the heartbeat counter for the next 10-second interval. And here is the draw graph function. In this if statement is used for if we reach the right edge of display, we clear the graph area and reset the x coordinate. And next, we clamp the signal value between 350 and 850 to ensure it fits on the screen. And next is map clamp signal value to a y coordinate between 0 and 40 and invert it since y equal to 0 is at the top of display. The next is we draw a line the previous point to current point and update the display. And the last two, last x and last y, we use to store the current point at the last point and increment the x coordinate for the next reading.